low temperature, heat shrink, self-soldering splices. Let's get straight to the point in this video, and let's test this, and then we'll do a little bit of analysis afterwards. So you're driving along and suddenly your vehicle stops. You've got a broken wire, it could be any application really. You strip the ends of the wire and you want to join them together. Normally you might use a butt crimp, where you put the two ends of the wire into a crimp and then crimp it shut and wrap a bit of tape around it. But you've got these things that supposedly shrink down. Let's test them right now. Okay, so let's give this a go. So I've already threaded this through the solder heat shrink device, and I've got the other end of the wire here. So I'm going to try and just sort of smoosh these into each other so they're roughly intermixed, and then feed it in without snagging the edge of the... I have completely snagged the edge of it, but let's see if I can get it through and into the middle. And then we shall activate the heat gun. I think the best approach here might be to shrink down at least one of the glue bands first. So let's do that. Okay, so I shall rotate it in front of the hot air gun here, which is currently set to about 300 degrees Celsius. I want to actually use it at that low temperature just to see if it does actually work with the solder. So that's kind of done like that. Should I... Yeah, let's just move on to the solder now and see what happens. So I shall rotate this in front of the heat. And it is melting. That's pretty interesting. And it's flowing in amongst the copper strands. I don't see any sort of liquidy flux as such, but I do see what looks like proper mating onto the copper. Whether it has mated properly is something that we'll find out when I take it apart afterwards. And then let's do the other band here. So this is the other hot melt glue band that is going to basically grip onto the wire and seal it against water ingress. Okay, that looks pretty good. That worked relatively well, but what really matters now is whether that solder in the middle has actually flowed properly. Let's cut the joint open and find out. Okay, let's see how close I can get it here, and I'm working in a very small area right now. So looking up the end of the wire, because I cut it in half down the middle first, you can see the solder has bonded on the outside, but it's not quite penetrated to the middle, and that is shown when you split it in half. You can see it hasn't penetrated right into the middle of the core. Maybe I didn't apply enough heat, or maybe there just wasn't really enough solder to do that. I'm thinking maybe not enough solder, but ultimately it has bonded the outer conductors together. It looks as though it's flowed amongst them, so it's probably produced a fairly acceptable solder joint. Hard to say how good that is. I don't have as much confidence as I would have if I'd actually used solder and a flux and a solder iron directly into this and then put hot melt heat shrink over it. But having said that, this is definitely a lot easier, and it's a very good quick fix. But as you can see, it just doesn't seem to have quite the penetration of a proper solder joint, but it's still probably better than the mechanical crimped connection. So let's test the other option here. Let's put these two wires together, two red wires. They're smushed together in the same way. Let's flow some solder in and compare the connections. So I'm just going to basically heat these and flow some solder in. And because, well, it's open, I can actually flow a lot more solder in. I can flow solder in until it is just basically a huge blob of solder in the middle. And because I'm applying heat directly to it from a solder iron, it's a fairly acceptable amount of heat. Am I happy with that? It could take a bit more solder. Let's add some more solder. Let's just keep smooshing the solder into it. Smoosh, it's the word of the day. I think that solder is actually wicking up the strands. So maybe that's not a huge advantage then. Let's let that cool down a bit. The solder's wicked up to about... It's not too bad. And at this point you could then, if you'd have the heat shrink on beforehand, you'd just slide it down over there, and then you'd shrink it down if you had this hot melt heat shrink. I can see that these devices have their advantages. You know, it's nice that it does everything in one package. What we've got inside here, we've got basically a piece of heat shrink sleeving that they've had a machine has placed in the two layers of the hot melt, the two hot melt rings, and then it's placed in this low temperature alloy solder, which feels quite hard. Tell you what, let's go down to the bench. Let's zoom down a little bit. Not too much, otherwise it starts losing quality of image. Let's bring the hot air gun in. And let's see, is it actually hot melt? Oh, hold on. It does. It's just absolutely gooed out into a big... Yes, that is definitely hot melt glue. That is very gooey and sticky. What about this? The solder. It's very crinkly looking. I thought I may have seen just a touch of flux there. But that is melted at fairly low temperature. How low temperature am I going to burn myself? It's sticking to the fingers. But it's not super ultra hot. Yeah, it's fairly hot. It's very strange that it is such a low temperature solder and then instantly reforms once you actually heat it up again. And other than that, the outer sleeve is just standard heat shrink. I don't think it's glue lined in its own right. I shall find out shortly by touching it and seeing it get burnt. Nope, it's just standard heat shrink. Oop, drop the heat gun. So yeah. Interesting. It's unusual. I wonder what the alloy is in this. Feels strangely light as well. Not sure what that is. Although obviously a pool of solder that size wouldn't convey much heat information anyway. Right, tell you what, I'm just going to, just for completeness, without zooming up this time, I'm looking for my knife. I have misplaced the knife. There's the knife. I'm going to chop this solder joint. I'm just going to take it off shot momentarily. Oh, that is much harder to chop through. That is very much harder to chop through. I'm completely failing to chop through that. Where are my schnips? Let's just chop through this here. Oh, there's so much more solder in that. Oh, it's all the way through, which is what you'd expect because of the amount of flowed in. I'm not even going to have to crop that up the middle because ultimately I know fine well that it is solid. It's all the way through. So the answer there is that these things, they work. They're probably more convenient than the butt crimps, but they're not as good for if you've got a high current carrying application. I think I'd rather solder it with a proper solder iron, but it might at least get you out of a tricky situation. And in certainly in low current applications, it could be enough to actually do the job completely. And for this a long term, I like the fact that it has the hot melt at the ends that actually closes in and seals around the cable. That looks quite interesting. Not convinced that these big, huge ones, if you had cables this size, that the little band of solder in there would actually do an awful lot. But for the smaller sizes, it's probably more than enough because it is roughly the same sort of thickness look of it. But there we go. Interesting things. And to be fair, they do work.